Okay, in this lesson today, we're going to talk about parabolas. So some of the characteristics of parabolas. For a quadratic function, and by the way, this f of x we call function notation. It means the same thing as y, okay? So y is equal to f of x. We know that we talked about this being standard form before. Ax squared plus bx plus c, standard form of a quadratic. What is the graph of a quadratic called? Yes, a parabola. If A, which is what we also call, A is called the leading, does anybody know? Coefficient. If A is positive, if A is greater than 0, that's the other word for positive, right? The other code for positive. What will the parabola do? It will open, yes, open upward. If A is negative, meaning A is less than 0, the parabola will open downward, exactly. And that's like you can think about the parabola as negative, it's a frown. If the parabola is positive, it's a smile, right? Okay, what about the axis of symmetry? How do we find the axis of symmetry? We were alluding to this last class. We use x equals negative b over 2a. And by the way, that's part of the quadratic formula, right? You remember we saw that when we were doing the quadratic formula. We had part of the quadratic formula, the negative b over 2a part, is the axis of symmetry. The axis of symmetry cuts the parabola in half. So here would be x equals negative b over 2a. And then if you add and subtract the square root of b squared minus 4ac from that number, that's where you get this idea of symmetry from. You would get the x-intercepts here. So we have, sometimes we'll have, how many possibilities of x-intercepts can we have? Yeah, we can have at most 2. So these points here would be the x-intercept. What about the point that crosses the y-axis? What do we call that? Yes, that's the y-intercept. And by the way, the y-intercept would be whenever x is 0, we have 0, comma, c. That constant at the end, once you plug in x equals 0, the only thing left is c. So that y-intercept will be 0c. And then notice, what is this point at the very bottom of the parabola? And by the way, these are arrows on the end because that keeps going. What is that very minimum point called that's on the axis of symmetry? The vertex. The vertex is on the axis of symmetry, and the coordinates for the vertex are going to be negative b over 2a, because that's your x-coordinate, right? And then to find the y-coordinate, what do you do anytime you have an x-coordinate? What do you do with an equation to find the y-coordinate? You would take the x and you could plug it in, and that's going to give you your y-coordinate. So essentially we call that f of negative b over 2a. And all that means is you took the x-coordinate and you plugged it into the function for x. You did all the math, and you got the y-coordinate. So that's our ordered pair. Any questions about that so far? So right here you can say these two, this one is probably negative b minus the square root of b squared minus 4ac all over 2a. That's what that one is. And then over here, this would be negative b plus the square root of b squared minus 4ac all over 2a, right, from the quadratic formula. So that point, comma 0, comma 0, and then this point, comma 0, would be our two x-intercepts. Okay, let's graph the function now. So we're going to put all of this together in order to graph the function. So this is an actual function as opposed to just that sample one from before. The first thing we want to do is think about where is the center of the parabola, where is the axis of symmetry. So we're going to take x equals negative b over 2a. So we need to identify first what are the coefficients a, b, and C. Who can tell me what A is? 1. Good. What about B? And C? Okay, so now we're going to take those numbers and we're going to actually plug them in. So we got that from our equation in standard form. And if we have negative B, that's going to be negative 4 over 2 times 1. And so that will be negative 4 over 2, which is negative 2. So x equals negative 2 is our axis of symmetry. And by the way, any number, when x is equal to a number, that's a vertical line. So we have x equals negative 2. That's our axis of symmetry. Now we want to find the coordinates of the vertex. So we were saying that we know the x coordinate, don't we? What is the x coordinate of the vertex? Negative 2. Someplace on this axis is where our vertex is going to be. And by the way, and if I look at this equation, is the equation opening upward or is it opening downward? And how do I know that? It's opening upward because A is a positive 1. So our parabola is going to smile. Probably the vertex is going to be someplace down here. How do I find it? Well, I'm going to take f of negative 2. I'm plugging in negative 2 for x. So I have negative 2 squared. And by the way, anytime you square a negative, when you're plugging that in, you want to make sure you use parentheses, plus 4 times negative 2 minus 5. So I get 4 plus negative 8 plus negative 5. And who can tell me what that is? Negative 4. Negative 9, right? Please tell me if you got the same thing. Okay, great. Negative 9. So if we plot that, we already know that our vertex is here. Let's plot and label it. Negative 2, negative 9, that's the vertex. Okay, now we want to find the coordinates of the x-intercepts. So we could use a lot of different ways to do this, but what is the main thing you know about the x-axis? What's the equation for the x-axis? I'll give you a hint. It's y equals 0. So if we want to find the x-intercepts, we're going to set y equal to 0. Basically, that means we take the equation and we set it equal to 0. And now we want to solve. So what are the 3 ways we talked about last time solving a quadratic? You have first way, factor. Second way, square root method. Third way, quadratic formula. Which way do you prefer? What's your favorite way? Factoring! I'm so glad. Mine too. Let's see, is this factorable? Well, I know that x times x gives me x squared. What times what gives me 5, negative 5, sorry, and adds to 4? Negative 5, oops, positive 5, negative 1. Why does the 5 need to be positive and the 1 need to be negative? Yes, because you want to have a positive 4, so that means your bigger number. Okay, now what does that mean x equals? X equals 1 and x equals negative 5. That means our coordinates. Now notice how it says coordinates. That's not the coordinates. What are the coordinates of the x-intercepts? 1, 0, and negative 5, 0. Why aren't they together? 1, negative 5. Why isn't that the coordinates? Because the y, remember we set the y equal to 0, and these points have to live on the x-axis because they have to intercept it. So I'm going to plot them. I'm going to label them. Negative 5, 0, and 1, 0. Okay, so now we have 3 points. You can see that these x-intercepts are symmetrical around the axis of symmetry. What about the y-intercept? Is the y-intercept hard to find or easy to find? Anybody know what it is? Yes, so when you set x to 0, what's the only thing that's left? Negative 5. So essentially f of 0 equals negative 5, because if that's 0 and that's 0, the only thing left is negative 5. So that's why we say the y-intercept is going to be 0c, right? That's the constant at the end once x is equal to 0. So if we plot that point, we have it right here, 0, -5. I labeled it. Who can tell me another point that, like, you see how this point is the y-intercept? Is there another point on the other side? And what could that point on the other side be? Like a symmetrical point. So how far away from the axis of symmetry is the y-intercept? 2 spaces away. If I go 2 spaces in the other direction, this point right here, -4, -5, is a symmetrical point because you see we have to have symmetry when it comes to our parabola. So once we have those points, and you should plot and label at least 4, but we might as well, you know, and make it beautiful. Put arrows on your end. Sorry that came out not as beautiful. So once we have all of those critical points, we can graph the function. Now, from previous classes, you might remember this words domain and range. What is the domain? What does that mean? The domain means all of the x values. And what's the range? The y values. So this might not make a lot of sense right now, but like can you think of any x values that you couldn't use? Or what are the x values that you could use for the parabola, to graph the parabola? It's actually, you can use all x values. So the domain is from -infinity to +infinity. Or you could say all real. That means the same thing as all real numbers. What about the range, the y values? Well, exactly, -9 to infinity. The -9, we put the bracket around the -9 because that means it's included. The number is included. And then we put a parenthesis around infinity, and that means the number is not included. Why can't I include infinity? Exactly. Infinity is not really a place that you can ever get to. It's a concept as opposed to a location. Okay, so any questions about this so far, graphing? Now what I want to show you is actually how you can check all of this using your graphing calculator. So if I get out the graphing calculator, I'm trying to make sure I can put it in a location where it will show nicely. We're going to go to our y equals menu. We can clear out what we have, and we can type in x squared plus 4x minus 5. We can press graph, and then my window is set up all weird from before. So here's how you would fix that. I want to just see basically almost like this exact viewing window, or a similar version of it. So the easiest way to do that is to go zoom standard. If you go zoom standard, it's going to change it to up 10, over 10, down 10, back 10. So you have -10, +10, -10, +10. And then, I don't know why the screen is so like washed out on this screen here. Okay. So that's what the basic shape looks like. And does that look like it pretty much is a match? It would be really hard though to plot the points from this screen onto the graph. So the easiest way to find the points, to confirm all these points, is to use the table. If you go second table, now you see in the table of values, you can see some of these points, right? Here is -5, 0. That's the same thing as this one, the y-intercept, or sorry, x-intercept. Then there's our symmetrical point that we found, -4, -5. If we keep scrolling, we can see the vertex. And you can kind of tell from the table that that's the vertex because you see the -2, -9. Around the -9, the numbers go down and then they come back up. So you see -8, -9, -8 means it's coming back up. You see the y-intercept, 0, -5, and you see the x-intercept, 1, 0. Okay, so those are some of the features of the calculator and how you can how you can check it